Dear students, greetings to all. Yesterday in previous video I started with isomerism, and I also briefly discussed about the chain isomerism with some example. Chain isomerism is nothing but same molecular formula having that different chain structure is called as a chain isomers. That phenomena is called as a chain isomerism. So here one more example I want to give to show that how it exhibit the same molecular formula with different chains. C4H10 is the molecular formula which shows that two different chain structures. One is that CH3, CH2, CH2, CH3. Another one is that CH3, CH3, CH, CH3. So the above one is the N-butane, N-butane, and second one is the 2-methyl propane, 2-methyl propane, 2-methyl propane. So same molecular formula, different chain structures. This type of isomers are called as a chain isomers. Chain isomers. Another one, C7H16. So we see that how many type of chain isomers are possible with this molecular formula. C7H16, we will see that CH3, CH2, 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 CH3. Another one is that CH3, CH, CH3, CH2, 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 CH3. So this is the another structure, and you also can write it as a CH3, CH2, CH3, CH3, CH2, CH3, and another one also you can write it CH3, CH2, CH, CH3, CH2, CH3, 4, 5, 6. Okay, and another structure also, another chain also is possible, that is CH3, CH3, CH2, CH2, CH3. So these are called chain isomers of molecular formula C7H16. Okay, so next isomerism is position isomerism. Next isomerism is position isomerism. Position isomerism is nothing but two or more different compounds shows the functional group or substitution in different positions. That means in any compound, compound with the same molecular formula showing the functional group or substitution in at different position of the carbon chain. For example, we see that molecular formula C3H8O, C3H8O. So here we will see that how it shows that different position of functional group, position of functional group. So this is the 1-propanol, this is the 1-propanol, and another one, the functional group on the second carbon, the functional group on the second carbon, so that is called 2-propanol. So 2-propanol. So 1 propanol, 2 propanol are the position isomers, or you can write it as a, for example, CH3 CH2 CH2 CH2Cl CH3 CH2 CHCl CH2 CH3. Okay, so this is the 1 chloro butane. This is the 3 chloro butane. So you can see the molecular formula: 1 2 3 4 carbon atoms, C4, and 6 7 8 9 H9Cl. So molecular formula is the C4H9Cl. So this shows that, or one more isomer also possible: CH3 CHCl CH2 CH2 CH3. This is called 2-chlorobutane. So these are the position isomers. Okay, and another isomerism is functional isomerism. Functional isomerism arises where the same molecular formula, different functional groups present. Same molecular formula having that different functional groups. So such isomers are called functional isomers, and that phenomena is called as a functional isomerism. So generally there are combination of the functional isomers like alcohols and ethers and ethers. Okay, aldehydes and ketones, acids and esters, alkenes and cycloalkanes. So these are the different combination of functional isomers. For example, alcohols and ethers, the same molecular formula can be exhibited by either alcohol or ether. For example, you take one example like C2H6O. So you can write it as a CH3CH2OH, or you can write it as a CH3OCH3. So this is the functional isomers. Here alcohol functional, here ether functional. So these are different functional groups with the same molecular formula. And aldehydes and ketones. Aldehydes and ketones, you can write it as a C3H6O. So you can write it as a CH3CH2CHO is the aldehyde, or you can write it as a CH3C double bond O CH3. It is a ketone. Okay, and you can also write it as a C3H6O2. So you can write it as a CH3CH2COOH, or you can write it as a and CH3C double bond OCH3. So this is the acid and this is the ester, right? So these are different functional isomers with the same molecular formula. I hope you understood. Still we have some more isomers that we will discuss in the next video. If you like it, share, subscribe, then it will reach more people. Thank you.